Hello again, and welcome to the OpenUK Mini-Moo lessons. This is lesson 5, and it's called Guessing Glove. You can start and stop this video at each step if you need more time to keep up with the lesson. Kim has played the rock, paper, scissors game on the Microbit website. She wondered if it would be possible to play a similar game on the Mini-Moo glove. But she's not sure how to do this and would like your help. Her problem is that the display on the Microbit is hidden in the glove pocket. She could get a pair of scissors and cut a hole so she can see the screen, but having seen the excellent projects you have already built with your glove, Kim wonders if you could make a similar game entirely driven by sounds and gestures. In today's lesson, you will help Kim to design a program for the Guessing Glove game. By doing this, you will learn about events, if statements, variables, defining a function, calling a function, random number generation, and you will also learn about the difference between source code and binary files. You will need your assembled Mini-Moo glove and the MakeCode web coding editor. Before we start writing the code, let's think for a moment about how this game is going to work. This is going to be a two-player game where you play against the glove. A normal rock, paper, scissors game has 3 different outcomes, which are based on 3 different hand movements. We can use different gestures on the Microbit, so let's use 3 different gestures as a way of communicating our moves. Let's use left, right, and screen up. Great, that's 3 inputs that we can easily use for the 3 moves, and that's the input sorted. For the processing, the Microbit can generate a random number, 0, 1 or 2, for the glove's move. It will generate a different random number each time. That means that you, the human player, can choose one of 3 different positions, and the glove can choose one of 3 different positions. The rules for rock, paper, scissors are a bit complex to code, so let's simplify it a bit and let the game decide if you have won or lost by checking whether the moves are the same. If you choose move 0 and the glove chooses move 0, you guessed correctly, and that's a win for you. If you choose move 1 and the glove chooses move 2, you've guessed wrong, so that's a win for the glove. Finally, let's think about the output. Well, that's quite simple. Let's use a high beep for a win and a low beep for a lose. Great. That's our input, process and output designed. Let's get on with writing the program. Let's start as we usually do by making the glove beep when it's turned on. You should be an expert at doing that now. Oh, hang on a minute. We need to decide how the game starts. Let's decide to use logo up as a way to start a new round. Let's code that up now. Grab an on logo up event handler from the input palette. To make it obvious that the round has started, can you make it beep 3 times? A simple way to get 3 nice beeps is to use the play note 1/8 beat block with a pause 500 after it. Finally, to start the round, the Microbit has to choose a random number. Fortunately, there is a block for that, but we need to remember this random number for later, so make a new variable called u and set it to a random number between 0 and 2. Your code should read set u to pick random 0 to 2. Flash this program onto the Microbit now and test it works. When you turn on the battery switch, the glove should pip to let you know it's running your code. And when you hold your hand up, like a stop sign, it should beep 3 times. Fantastic! It's now time to learn a bit about what a function is. In coding, a function is just a block of code that has a name. A really important feature of a function is that it can be used in lots of places all over your program. This is really useful if you have something that needs to happen in lots of different places. But the good thing is that you only have to write the code for it once. You could cut and paste the code lots of times, But that gets messy really quickly. If you find a bug in that code and you've cut and pasted it 20 times all over the place, the bug will be in 20 different places and you'll have to fix that bug 20 times. You might miss one of them. It's far better to hide the code away in a function and give it a name. When you want to use the code in a function, just imagine you're shouting out the code's name, and then the computer will run the instructions inside that function. We're about to write a function that checks the moves. So let's give it the name check. Whenever you want to check the moves, just imagine you're calling out the name check, and it magically happens. In computing, when we write the code for a new function and give it a name, we say we are defining the function. When we call out its name to run the code for that function, we are calling the function. When the code in the function finishes, we say that it returns back to the point in the program that it was called from. That's a lot of new ideas all at once, but it's really quite simple. So, let's define a new function. Under Advanced, you will find a Functions palette and a button called Make a Function. Press that button and give your new function the name check. It will appear in your coding area. The name of the function is defined, but we still have to put some useful code in it. The purpose of this function is to check the glove's move against the human's move and decide if they are the same or not. You already have a variable for the glove move. It's called U. Create another variable and call it me. That will be used for the human move. There are two different outcomes for this function. First, if the moves are the same, we need to beep a high beep to indicate a correct guess. Second, if the moves are different, we need to beep a low beep to indicate an incorrect guess. For this, you will need an if, then, else block. Go and get one of those from the logic palette now. You've used an if, then, else block before. Your code needs to read if U equals me, then play tone high C for 1 beat, else play tone middle C for 1 beat. Can you assemble the correct blocks together inside your check function now? That's great. So let's just recap. You have defined a function with the name check, and whenever it is called, it will decide if the U variable and the me variable are the same or not. If they are the same, it beeps a high beep, and if they are different, it beeps a low beep. Well, your program is not quite finished yet because you still have to call your check function. There are 3 different movement gestures your glove needs to sense for the 3 moves. These are on tilt left, on screen up, and on tilt right. Get those from the input palette now. There are 3 moves, so each move will have a different number allocated to it. Left will be 0, screen up will be 1, and right will be 2. Fortunately, we have this really handy check function that will do the hard work of checking the moves for us. So the code for these event handlers is now really easy. Inside on tilt left, the code needs to read me equals 0, followed by check. You can get the blue check block from the Advanced Functions palette. You should be able to work out how to fill in the on-screen up and the on-tilt-right event handlers now. See how easy it is to keep reusing the check function? It's really neat, isn't it? Well, that's the code finished. Flash the code to your microbit and make sure the game works. Play a few rounds and use different gestures and see if you can always second-guess what move your glove is going to choose. Can you get a good high score? Kim is really pleased with this game and will play it for hours. She has asked if perhaps you could add a score counter to it, a bit like you did for the Keep Up Glove game. You could have a go at that if you want, and the code will be very familiar. You will need a score variable to count every time you guess correctly, and a gesture that checks the score and plays different sounds or tunes based on what your score is. Have a go at that yourself and see if you can come up with a modified game that's fun and easy to play. There was one last thing that Kim wanted some help in understanding. She has heard there are two different terms used to refer to a computer program and doesn't know the difference between them. She heard about source code from Imogen, but she also heard about binaries. Someone mentioned a binary file. She's not sure what the difference is. Do you remember learning about source codes in an earlier lesson? It's the human-readable instructions you use to program your microbit and that you enter in the Make Code editor. But these instructions are not understood by the microbit. It speaks and understands a completely different language. The microbit, and almost any computer, understand computer languages that are groups of binary digits, ones and zeros, in different combinations. Each different combination of binary digits represents a different instruction in the language the computer understands. A file that contains these coded binary digits is called a binary file. In computing, we sometimes just lazily call these files binaries. They both mean the same thing. Right, so the source code is the human-readable version of a program, and the binary contains the program-readable version, or translation, of the same program. The Make Code editor has a built-in compiler that compiles all of the different parts of your program from source, human-readable, code, into binary, computer-readable, form of code. You use the binary to run on the microbit, so it understands, and you can use the source code for you to view and change what your program does. If software is open source, then the human-readable source code of the program is shared, and everyone who knows the language it is written in can read and change it. If all you have is a computer-readable binary file, then a person cannot read it or change it easily. It's hard work to try to recreate the human-readable source code from the binary file. Fortunately, the Make Code editor handles all the hard work for you. It compiles your source code into a binary file for the microbit to read, and it stores both the source code and the binary code inside the .hex file. You can download both. If you drag and drop this .hex file onto the microbit drive, it copies the binary part onto the microbit, which runs your code. If you drag and drop the .hex file onto the Make Code editor window, it reads out the source code for you, so you can view and change it. Well, that's another lesson over. Kim is super pleased with the game that you made her. She'll be playing this all day now. Remember to have a go at adding a scoring system for her. And don't forget, if you share your program as open source, you have to give the source code to the person you're sharing it with. See you again at the next lesson. Bye for now.